Hey guys, Brandoni Productions here. Welcome to the next video in my Python programming tutorial series. In this video, we're going to be discussing functions and how to use them. So let's get right into it, jump into our Python REPL. In this tutorial, as in all the previous ones, I'm using the Windows command prompt. However, this video will apply to any operating system. So, much like any programming language, Python has the concept of functions, which is basically things that you can perform multiple times, however you only define them once. So let's start with a simple case. So to create a function, you use the keyword def, which stands for define. So we're going to define a function, and we're going to call it hello. And the next step is to give it parameters that you can pass to this function. Right? So in order to declare which parameters a function accepts, you open parentheses. So in this case, we're just going to accept one parameter, and we're going to call it person. Then we close the parentheses and add a colon to indicate that we are starting the body of the function. Now the body of the function, each line starts with a tab, and then the next line without a tab in the beginning is the ending of the function. So in this function, we're just going to print hello, comma, plus person. So as you can see here, all we're doing is calling the print function, and then we're taking a string and appending another string, and this string is in the variable person. I'm going to press enter, and then to signify the end of the function, I'm going to submit a new line without a tab in the beginning. And we are ready to go. So now, if we actually take a look at hello, you can see that it is a function. So let's go ahead and call it. So we can invoke functions by saying the name, and then much like we created a parameter list, we can provide arguments to the function via parentheses. So my name is Brandon, so I'm going to provide the string Brandon. Hello, Brandon. So these are the basics of functions. You define behavior inside of the function. The behavior usually operates only on the variables that you provide, and then it will return a value. There are other functions that alter variables outside of their scope, and we'll talk about those a bit later. So I mentioned that functions return a value. However, in this function we just created, hello, it doesn't seem like it returns a value. But if we assign a variable, let's say value equal to hello, you can see that it prints out the thing that we wanted, and then we have value here. But what if we print value? We learned that value is none. So in our function above, we did not actually return anything. So let's go ahead and make it return something. So we're going to create a new function called makeHello, right? And it's going to do the same thing, except instead of printing a message, it's going to return a message. So we're just going to return hello plus person. So this is essentially the same thing as our previous function, except instead of printing, we're returning. So if we call it again, just like we did with hello, oops, Brandon, you can see that you can tell that it's returning a string because it actually formats the string like a string. So if we print make hello, Brandon, you can see that we have the same output as before. And if we say value equals make hello, Brandon, we learn that value is now the string hello Brandon. So this shows that functions without an explicit return value actually return none. This is kind of nice. It's kind of nice, but it's kind of not nice, right? So if you forget to type in a return value, your function will return none, and there will not be any exceptions raised. So you may not know that you forgot to type in a return function. Alternatively, you can have certain paths of your function not return something, and then by default it would return none. So let's go ahead and take a deeper look into this, this function signature. So if we create a function, let's just call this one fn, we can specify a list of parameters for that function. You might have noticed when I typed in the hello and make hello functions, these parameters don't have to be typed. Indeed, Python, as you probably noticed, doesn't have a very explicit type system. It's a strongly typed language, but you don't actually have to declare the types inside of the functions and signatures that you create. So we can just say value here, and then if we print hello plus value, this function will work for every value that is able to be concatenated to the end of a string. So that's pretty much everything, actually. So if we call function with Brandon, like before, we get the message. If we call function with 1, you can see that actually we cannot append a string and an int together, right? So this function implicitly does not accept integers. We can try other things. What about a list? Yes. So although we did not actually do any type declarations inside of our parameter list, you can see that our function implicitly converts the type of the argument to the type of how it is used inside of the body of the function. This is called duck typing. So the function will only allow things to go all the way through that its body accepts. Of course, it's not the function itself that does this, right? You can actually check. The error is coming from line 2 of function. So if we were to have other values inside this function that allowed integers, those would still proceed normally. It's just this print function that has an exception. So a little bit of interesting behavior. So I'm going to give you an example of a function that takes multiple arguments, right? So let's take a function. Let's make a function called pick second, right? It accepts a list. Let's call the list L, and it accepts a string S. And all it does is prints the second element of the list and appends S to that message. So we're just going to say print L1 plus S. So you can see this is actually a little bit confusing because there's no types. We don't actually know what's happening here. And the behavior can definitely vary between different types. So if we pick second with a list of strings, hello world, and then the string we provide is Brandon, you can see that it prints world Brandon, as we expect. How about if we pick second with just one string, hello Brandon? So we've done some duck typing here. So we have hello provided. It's not a list, but we never said anywhere that this has to be a list, right? So it actually, the pick second just takes whatever you provide it in the first argument and takes the second element. So in a string, it's an element, or it's a list of characters. So the second element here is the E. The second parameter is Brandon, so it just appends it and prints it. Now what happens if we actually submit a list of integers? And for S, we provide another integer. So here it just takes the second element, which is 2, and it uses the plus operator. So with integers, the plus operator does not append an integer to another integer, but rather it will add the two integers together. So we get 7. So in Python, functions can do many, many different things depending on the input types if you do not properly assert your types. Of course, this is actually, most pure Python programmers will tell you that this is how it should be, right? You should write generic functions, and they should operate on only the most generic types. And you're able to do this by just letting Python handle all of the type conversion for you. So arguably, pick second is operating as intended. So one more thing about functions in Python is that they are objects themselves, right? So if we declare a function, it takes no arguments, and if you don't have the body for a function, you have to use this special Python keyword pass, which essentially will be a body that does nothing, right? So we have this empty function, pass, And you can see that if we query for what this function is, you can see that it's actually an object. It is a function. Indeed, if we type of hello world, it is a function. So what does this imply? This means that we can actually take the function and pass it around to other functions. So let's go ahead and experiment with that. Let's create a function. And all the function is going to do, it's going to be, let's call it map, right? And this map is going to take a list of things, and it's going to take a function. And all it's going to do is call the function on each thing in the list. So for item in list things, call function item. Great. So now we have a function called map, right? And the second element is function. So what happens if we define a new function? Let's call it print item, right? And it will take an item, and all it does is print it. Okay, so now what happens if we call map with a list of things, 1, 2, 3, 4, 5, and the function is print item? Ah, it printed every item. Fantastic. Now actually we can take this a step further. You can see that our print item function essentially just calls print. So why not just pass in the Python function print here? Ah, great. In fact, map is already included inside of the standard Python library. I believe it's in functools. Okay, well, I actually don't know where it is. Sorry about that. I actually paused the video, and here we are. So our previously defined map is actually included inside of the Python library. Check this out. Oops. Check this out. So, as you can see here, the Python standard library map actually does exactly what we did, except instead of only calling the function, it also takes the return value of the function and puts it inside of a list for us. So it still printed out the values, however, it also took the return value of print for each item, and print doesn't return anything, it just prints. So none, 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 none. So this kind of passing around of functions and dealing with functions in this way is an aspect of functional programming. Another aspect of functional programming is that each function may not edit stuff outside of its function, known as side effects. So let's go ahead and go over side effects really quickly. So if we have a variable v equal to 5, and then we have some function, it's called something, and we pass in a variable called key. So all this function does is it prints the key, and then it increments the value of v by 1. So if we call something of hi, you can see that, so two things to notice here. The first thing, key, everything is fine, right? We pass in key to the function, and then it prints the key. Second thing to notice is that the function actually performs a mutation on a variable outside of the function scope, namely v, right? This seems to be okay, right? We declare v above the function, so we should be able to edit it inside of the function. However, Python is a little bit opinionated on this. The big problem is Python has no difference between declaration and usage with its equal sign operator, right? So saying, if we were to just say def something key, print key, v equals 1, everything would be fine here, right? If we call something hi, everything works. However, if we query v, we see it's 5 and not 1. That's because this particular syntax is creating a new variable called v, and it's not touching the variable outside of the function. So in order to tell Python that you actually want to touch the variables outside of the function, you have to use the keyword global. So let's try this again. Something key. Print key. Now we need to tell Python that we want to work with a v that was declared outside of a function. So we basically just say global v. Now this is telling Python, hey, v is declared, it's outside of this function, I'm about to use it. So now we can say v equals 1. And then if we call something hi, we get the print, everything's fine. And now if we query v, we can see that v equals 1. So these functions are not pure functional functions. They have side effects outside of the scope of their own body. However, this is kind of nice for simple hacky scripts. You just want to share some state between functions. You can use global variables, and you do so with the global keyword. So this was just a little something about functions. There's actually a decent amount more to cover about functions. We'll get into those in future tutorials. For now, thanks for watching and have a nice day.